All right, so I wanted to take a moment to explain how annuities work and to show the derivation of the formula for a future value of an annuity. Now, an annuity is where you're paying in a set amount of money on a regular basis, and what we're going to be talking about here are making monthly payments into something, and for the sake of simplicity, we're going to keep those monthly payments the same every month. So we're going to use that to derive a formula that will allow us to predict in the future what this annuity would be worth. So annuities, when you start them, you start by putting the first monthly payment in. So we're going to call M the amount of the monthly payment, and we're going to call W the working interest rate. Now the working interest rate, if you recall, we talked about this in class, is the APR, the annual percentage rate, divided into equal parts. Now in this case, since we're making monthly payments, that would be the APR divided by 12. So when I make one payment into the annuity, my value of the annuity is just that monthly payment. It hasn't earned any interest. When I go to make the second payment, that second payment gets put in, but that first payment gets assessed a month's worth of interest, which is basically multiplying it by 1 plus that working interest rate. It's the 100% plus the percentage added. So that's after 2 payments, and after 3 payments, that first payment gets assessed to the interest again. The payment that we put in last month now gets its first dosage of interest, and we put in another payment that hasn't earned any interest yet. And this keeps going. You can see the pattern here. Again, earning another payment of interest, payment of interest, payment of interest, hasn't earned anything yet. So you can see when we look at this pattern that we have several terms here added together that look the same. And the pattern is that there's always an M, there's a 1 plus W, and it's being raised to a different power. And that power is 1 less than the number of payments. So if we take that pattern and we actually write it out mathematically, this is what it looks like. If N is the number of payments, the first power on that interest assessment is 1 less than the number of payments we put in. And this goes all the way down to M. Now, this is okay. This is a mathematical formula, but it's totally useless for what we would like to do. If I had something where I was investing for like 20 years, that's 240 payments. I'd have to calculate 240 separate things and then add them all together. That is way tedious. So we're going to use a little mathematical trick to turn this from something that's long and tedious into something that's nice and compact. So we're going to take this equation that we've got right here, and we're going to multiply both sides of that formula by 1 plus W. And when we do that, this side becomes V times 1 plus W, clearly. And then when you multiply each of these terms by 1 plus W, the 1 plus W term there gains a power. So if it started as an N minus 1 power, it turns into an N power. And an N minus 2 would turn into an N minus 1. And an N minus 3 would turn into an N minus 2, and so forth and so on. This M times 1 plus W to the first would go to the second, and this last one that doesn't have a 1 plus W would go to this. So that gives us another equation to work with. So we're going to take that equation and the equation we had originally, and we're going to do an elimination step by doing subtraction. So let me pull my work up here. So here we have the equation that we just created, and here we have the equation that we are subtracting, which is the one we started with. So when we subtract these two things, I've lined it up where all the terms that go together actually are lined up on top of each other. Now the original equation has an M term, and the one we created doesn't have just a plain N term, so I left it off to the side. And the equation that we created has a 1 plus W to the N term, and the one that we started with didn't have one. But if you look at all those middle terms, the N minus 1s, the N minus 2s, all the way down to the squares and just the plain 1 plus W's, those are all, when I subtract the equations from each other, going to go away. And so what I'm left with is this really nice compact piece here, where I have V times 1 plus W minus V on this side, and then these two terms, the first term, which didn't have anything lining up with it, going here, and here, a minus M. All this stuff in the middle subtracts away, and it gives us something that's really nice and compact. So I'm going to bring this down here. There it is written more closely together. Now, if I wanted to solve this, I'm going to distribute this V to the 1 plus W. That would give me this V plus VW minus V equals this nice compact thing that we have. The V and the minus V go away. And so basically, if I want to solve this thing for V, all I have to do is divide both sides by W, and that gives me this formula. Now you'll often see it written in resources like this because the M here and the M here can be factored out and then pulls off the fraction. So that's the formula for the future value of an annuity, which we will use to derive what's called the present value of an annuity.